So example 1.7, right, what does it state? Consider the charges Q, Q and minus Q placed at the vertices of an equilateral triangle, right, as shown in the figure 1.10. So there are three charges which are placed at the vertices of an equilateral triangle, Q, Q and minus Q, right? Yeah, Q, Q and minus Q. So what is the force on each charge? Right. So they have not given any vertices, right? Okay, they have given this as A, B and this as C, right? So our job is to find the force on each charge, right? So what do you mean by that? First point, whenever you look at this problem, what is the first concept that should come to your mind? There are two things available. One is they told point charges. So wherever you see point charges and the concept of force comes, the first thing that should come to your mind is Coulomb's law. Satisfied? Okay. Second, you will be able to directly apply Coulomb's law and solve the problem only if you have two charges. If it goes for more than two charges, then you need to think of the concept of principle of superposition. So principle of superposition always states what is the force experienced by one of the charges due to the remaining parts of the system, right? So the question is very clear. What is the force experienced by each charge? So if I want to calculate the force experienced by A, if I want to calculate the force experienced by the charge at A, then it is going to experience a force due to the charge at B and C. Simple, right? So if I start giving a number to it, 1, 2 and 3, right? So the charge at A due to B will experience a force in which direction? Both are positive. So this will experience a repulsive force in which direction? In the leftward direction, right? Accepted. What is the name given to this? F1? Correct. F12. So what about the force experienced by this charge due to the charge at C? It will be a attractive or a repulsive force. Attractive means it is pulled towards this. Means it should act in this direction. So if you observe the textbook, right, they have given you the directions, but let's not be concerned about it. Okay, let's assume if it was not given, how are we supposed to find it, right? So I'll call this also as F, but what is the name I'll give to this? 1, 3, right? So if you draw a separate diagram for the charge at A, one of the forces is in this direction with the name F12 and the other is in this direction with the name F13, and what is going to be the angle between both? So this is 60, so this is a linear pair, it is going to be 120. So it is going to be 120 degrees. Am I clear till this step? Right. Next point is, yes. So since I have these two forces, I need to find the value of F12 and F13 by applying which law? Obviously, Coulomb's law. Right. So what is going to be the value of F12? It is going to be K is in your mind 1 by 4 pi epsilon naught. So K times the product of magnitude of these charges. How much is it going to be? It's going to be Q into Q, which is a Q square, divided by the distance of separation between them. So if I take the side of the triangle to be A, it is going to be A square. Makes sense? Right? Similarly, if I take F13, what is it going to be? K Q into, this is where we made mistake. Just take modulus. I told you, in Coulomb's law, we take the product of the magnitude of the charges. Why? Because the direction is already taken care. Right? So wherever you are dealing with vectors, have this in your mind. You need not take the sign of the charge into consideration, provided you already know the direction. Is the point clear? Right. So K into, it is also Q square divided by A square. Right? So in terms of magnitude, F12 is exactly equal to F13, but not in terms of direction. In terms of magnitude, they both are exactly the same. So I'll call it as F. Can I? Right. So, since I have two vectors which are co-initial, then we need to apply a law from vectors which is called as parallelogram law of vectors. So, here I would like to stress on one point. Yesterday we discussed about triangle law of vectors. So, triangle law of vectors speaks about two sides being continuous and the third side being in the opposite direction. Whereas, you need to apply the parallelogram law to find the resultant when you have two co-initial vectors, means if the starting point of both the vectors is same, right? So, this is F, this is F. So, what will be the answer? The resultant will be equal to square root of A square. I'll tell you the formula. It is A square, that is F square, plus B square, plus 2 times A into B, F into F, into cos of the angle between those two vectors. How much is it going to be? It will be 120 degrees. Right? Now, having said this, root of F square plus F square minus 2F square. Okay, I'll write it later. It is plus 2F square into cos 120 is minus half. So, 2 and 2 are gone. So, this F square and minus F square are gone. So, square root of F square is going to be F itself. Means the resultant force experienced will be F itself. This and this put together, when they are at an angle of 120 degrees, it will form F itself. Where? Now, 1F square and 1F square will get cancelled, no? Because cos 120 is minus half. 2 and get cancelled. So, this is minus F square, right? So, the resultant will be F. Now, the next question is, what is the angle at which it is acting with respect to both the vectors? Here also, I would like to stress on another point. This is an important point which I am going to tell because we will apply it in one of the derivations. Okay, I want you guys to make a note of it. Whenever two vectors are of equal magnitude, make a note of this point. Whenever two vectors are of equal magnitude, then the resultant will always be an angular bisector. The resultant will always be an angular bisector of the vectors for which we are finding the output. Okay, please make a note of this point clearly because we will apply it in a concept called as equatorial plane, equatorial point. Okay, remember this, and in magnetism also. Right, now we understood the statement. Let's try to apply it here. So, what is the meaning of that statement? There are two forces which are of equal magnitude and for which you are finding the resultant. So, according to that statement, what should happen? The resultant will exactly be an angular bisector of the angle that is existing between these two vectors. So, how much will this angle be? This will be 60 and this will also be a 60. Am I clear with this? Right. This idea also comes from the parallelogram law of vectors only. So, what we did is, we tried to calculate what is the force experienced by the charge that is placed at A. Right. So, first copy this, then I will give you 5 minutes time, you solve and tell me for B and C. இப்போ ஏசி பெட்டரா இருக்காங்க, கொஞ்சம் பரவாயில்ல, கூலிங் இல்லை, ஆனால் ஏசி போட்ட செகண்ட் நாளே போட்ட நம்ம கிட்ட இருக்க எங்க ஏசி அந்த ரூமுக்கு ரெண்டு போட்டால் தான் கூல் ஆகும். பெரிய சைஸ்ல 350 ஸ்கொயர் ஃபீட் அது. இன்னைக்கு ஆங்கிள் நல்லா இருக்கு. நான் அப்பப்போ இதை செக் பண்ணிட்டு இருக்கேன். ஆனாலும் அடிக்கும்ன்றியா? என்னதான் இருந்தாலும் கடைசியில நான் சொல்றது தான் கன்வின்ஸ் ஆகிறேன். பால்ல இருந்து ஆரம்பிச்சு ஜூம் வரைக்கும். இதெல்லாம் கூட ரெக்கார்ட் ஆகிட்டு இருக்கு. அதை நம்ம கட் பண்ணிடலாம். You calculated for B? Correct on there. Why cos 60? For B is what you are calculating, no? C. C is correct, cos 60. So let's do for B, right? So for the charge which is at B, due to the charge at A, what will be the direction of force? Rightward or leftward? Rightward, because it's a repulsive force. So what is going to be the value? F 21, correct? What about this one? So will it be upward or downward? Upward, because it's an attractive force. So it will be F. How much? It's F23, no? It's F23, right? So when you calculate the magnitude, what will be the value of F21 and F23 in this scenario? It will still be the same, right? KQ square divided by A square. So the angle again is going to be 120 degrees. So what will be the answer? The same F which is making an angle of 60 degrees with either of the vectors. Am I right? So what about the charge at C? So charge at C is going to experience an attractive force due to this. What is the name of this? F. What about this? What is the angle between both? 60, right? So both are of same magnitude, right? So what will be the resultant? Root of F square plus F square, F square plus F square plus 2F square, because you will get F into F, cos of 60. So cos 60 is how much? I'll directly write it. 1 by 2. So cancel this and this. So root of 3F square, which will give you an answer of root 3F, which is right. And what is going to be the angle made by the resultant? 30 degrees. So it's going to be 30. That's it. Is that clear? Right. It's a simple problem. Now I hope you got a grip of how to apply these vectors, right?